Hello guys, well now we're gonna do problem 11.10, which is this one right here. And the first thing that it says is to draw a free body diagram. I drew all the forces and the weight of the ladder in the middle and the weight of the man at 1 meter from the bottom. We have the friction force, which is pointing to the right because the ladder will be slipping to the left in this case. The first question that we have is what is the maximum friction force that the ground can exert on the ladder at its lower end? And we can find that using the friction force is equals to mu times the normal force 1. To find the normal force 1, I did the sum of the forces in the y direction, which is positive n1 minus the weight of the man minus the weight of the ladder. And I solved for n1 to get 900 newtons. After that, we can plug it in on this formula, and the maximum friction force is 360 newtons. Now part B says what is the actual friction force when the man has climbed 1 meter along the ladder. For this, we will be using the sum of the forces and the torque of A, and is all this right here, but since we are rotating around A, the friction force and the normal force 1 are gonna cancel out, and we are left with this other three. We get this formula, and one of the things that I did right here was to multiply the distance times cosine of this angle, because we want to find the distance in the vertical direction. And to find the angle, what I did was I took cosine inverse of 3 divided by 5 to find this angle. And after this, we get that N2 is equal 171 newtons. For part C, is asking how far along the ladder can the man climb before the ladder starts to slip. For part C, we'll be using a very similar formula, but in this case, we're gonna be trying to find the distance. As you can see, I just rearranged the formula a little bit, and after we plug in the numbers in the calculator, we get 2.70 meters, and that is the answer.